We're talking about solving polynomial equations, and for this one we're going to talk about using the rational root theorem. And the rational root theorem says if you have f of x is a polynomial, and here's the polynomial, this just says that the polynomial has highest degree n with leading coefficient a sub n, and it goes all the way down to a constant term a sub o. Has integer coefficients. So if the polynomial has integer coefficients, then every rational zero of the polynomial has the following form. And the form is p divided by q, where p is a factor of the constant term. And the constant term in this case is a sub o. So a sub o for this example is going to be 12. And q is equal to a factor of the leading coefficient a sub n. So we have a sub n is the leading coefficient. So what does that mean? A sub o, we said a sub o is equal to 12. So that means that p can be any factor of a sub o. So any factor of a sub o includes the positive and the negative. So we can have positive and negative 12. We could have positive and negative 6, positive and negative 4, positive and negative 3, positive or negative 2, or positive or negative 1. And for a sub n, we know that a sub n is 3. And so that means that q can be any factor of that. So we can say plus or minus 3 or plus or minus 1. So we have to represent all the possible options for p divided by q. And so what we have to do then is we have to write this out where we have each one of these possible factors divided by this possible factor, and then we do the same thing divided by this possible factor. So as we get started, we can just write down all of these, and we're going to talk about p divided by q. So p divided by q, in this case, p is 12 plus or minus 12 divided by 3. Then we have plus or minus 6 divided by 3, plus or minus 4 divided by 3, plus or minus 3 divided by 3, plus or minus 2 divided by 3, and plus or minus 1 divided by 3. So that's for all those factors divided by 3, but then we have to do it again for all those factors possibly divided by 1. And so then we have to do plus or minus 12 divided by 1, plus or minus 6 divided by 1, plus or minus 4 divided by 1, plus or minus 3 divided by 1, plus or minus 2 divided by 1, and plus or minus 1 divided by 1. So those are all the possible options, but we have some duplicates. Because we know that plus or minus 3 divided by 3, this is actually equal to plus or minus 4 when we do that math. Plus or minus 6 divided by 3, this is actually equal to plus or minus 2. Then we have 3/4, and then we have plus or minus 3 divided by 3, that is equal to plus or minus 1. So we don't want to write down duplicate numbers. So for our final answer, we want to have p divided by q So that is going to be equal to plus or minus 12, plus or minus 6, Those came from there. We have plus or minus 4 twice, but we only have to do it once. We only have to write it down once. Plus or minus 3. Plus or minus 2. That comes from here and from here. Plus or minus 4 over 3. Plus or minus 1, which comes from here and comes from here. Plus or minus 2/3. And plus or minus 1/3. So this will help us out if we have a polynomial that we're trying to factor. This will help us come up with the possible roots, so that we're not trying an infinite number of values for our 0, and we can just focus in on a few.